Okay. By first order linear, I mean differential equation of the following form. Y prime plus a function of x times y equal to another function of x. Okay, let me first explain the terminology here. Order of a differential equation is how many times the derivative is applied at most to a function. So y has only one single prime, therefore this is a first order differential equation. If I had another term like here y double prime plus y prime and so on, then y double prime would make this differential equation a second order differential equation. Okay? Knowing the order of a differential equation is important because the number of derivatives actually tells you how many undefined free parameters you would have. Okay? So that's what order is. Then this part about linear. Linear means that y prime and y, they're at separate terms. They're never multiplied to each other. They're just by themselves separately. And their powers are always 1. Okay? So if I had y squared somewhere, that wouldn't be linear. Okay? If I had y prime squared, that won't be linear either. Okay? Linear means whenever y prime or y appears, it only has first power, and it never happens that these y prime and y are multiplied together. Okay? That's what linear means. Okay. For such a thing, we can come up with something called the multiplier. And when you calculate the multiplier and multiply to the given differential equation, suddenly the left side turns into a product rule, and you can solve the differential equation. Okay. So for now, let me just show you the formula for finding the ideal multiplication, and then afterwards I'll try to explain why that formula does work. Okay. So I'll just throw this formula in. Multiplier is defined as e to the integral of p of x dx. And usually when you do these integrals, you have plus c there, right? Here, I don't want you to put plus c. I just need a single function that will turn this left side into a product rule so that you can integrate both sides. Okay. Now, to really understand what this formula means, I need to show you an actual equation to solve. Okay. So let me show you this first differential equation. Example 1. Suppose you have y prime plus 1 over xy equal to just let's say 3. Let's make it simple. Okay? Suppose you have such a differential equation. How do we solve it? This. Okay. The first thing that you have to see is that if you put this term to the other side, you have 3 minus y over x, and no matter how you try, you will see that you can never put that into a function of x times function of y. So, in other words, this is not a differential equation which is separable. Therefore, you can't use the method that we learned for solving separable equations to solve this. We need a completely different strategy.
Wait, why can't you do that?
I mean, just try it. Just if you move this to the other side, you get, first of all, 1 over x times y is y over x, isn't it?
Mm-hmm.
So if you move it to the other side, y prime is 3 minus y over x. And that's like 3x minus y over x. Can you write this as a function of x times function of y? I don't know how to. So I think that's pretty much clear, right? So this is not a separable equation. It is first order differential equation. There are some few cases where they're both. Okay? In that case, you can use either methods for solving first order linear differential equation or separable. Either one will give you the same answer at the end of the day. But this one, you can't solve it as a separable equation. You're stuck with the first order linear. Okay, now let's compute this magic function, and for, well, not for magic, but multiplier function. It's integral px is 1 over x. And if you integrate 1 over x, that's ln of x. And they cancel and you just get x. And once you calculate this multiplier function, you multiply this to both sides, and suddenly the left side turns into a product rule. And then, so now let's witness this magic. Multiply by x. If you multiply by x to this one, what would you get? X times 1 over x is? 1, so that's going to cancel away, and you're only going to get 1, right? How about the 3? That turns into? 3x. Because I'm multiplying x to everything. All of the terms will get x multiplied. And then, now you can verify my claim that the left side is a product rule of something. So think about the following. What would you apply product rule to so that the left side becomes this? Now, if you forgot the product rule, what's the product rule? F times g prime is fg prime plus f prime g. Right? So instead of g, what's there? Y is there, isn't it? Instead of f, what's there? X, right? So if you compare this one with the left side, you see that it's actually x times y prime, which is equivalent to the left side. I mean, just try to differentiate x, y prime using this rule. What is it? Leave the first one, differentiate the second one. Leave the differentiate the first one. Leave the first one. Leave the second one. And the derivative of x is 1. So you have xy prime plus y. Exactly same as this, right? So this left side can be rephrased as this. And why is that good? It's good because now it's easy to integrate. Let's try to integrate this. Now, if you differentiate and then integrate, what do you get? Same thing. Integration and differentiation is just opposite operation of each other, right? So if you took a function, differentiated it, and integrated it, you get the same thing all over again. Okay. What about the right side? 3 over 2x squared, right? Plus c. You have to put this plus c on one side. Actually, I mean, technically you have to put c1 and c2 plus c1 plus c2, but that plus c1 can be moved to the other side and thought as a single constant. Okay? It can be thought as a single constant. All right, and then you divide by x, and that's your answer. X squared divided by x is x. C divided by x is c over x. And this is your solution. If you want to, you can actually check whether this is a solution just by differentiating once and then plugging in. And let's do the verification. I want to skip it, but verify. What's y prime? That's 3 over 2. 1 over x differentiates to negative 1 over x squared, right? That's y prime. So if I had y prime plus 1 over xy, if I had this, then y prime is 3 over 2 minus c over x squared. And plus, if I took this and divided by x, I get 3 over 2 plus c over x squared, right? So that these two cancel each other. And 3 over 2 plus 3 over 2 gives you 3. which is indeed same as the right side. Therefore, we see that this solution we found does satisfy our differential equation. Do you have a question? Yeah.